In this video lesson, we're going to learn how to calculate the molar mass of substances and then take the molar mass to calculate the number of moles and even the number of particles in a substance. So the molar mass is the mass of 1 mole of an element or compound, and the value is equal to the atomic mass, but this time it will be in grams. So the atomic mass of hydrogen is 1.01 atomic mass units, and the molar mass of hydrogen is 1.01 grams per mole. The molar mass of a compound is the same as the sum of the molar masses of each atom in the molecule. So, for example, if we were to find the molar mass of water, there are 2 hydrogen atoms and 1 oxygen atom. So we have to add the molar masses of each of those together. So it would be equal to the 2 times the molar mass of hydrogen, and capital M, by the way, is the symbol for molar mass, and then plus 1 of the molar masses of oxygen. So that would be 2 times 0.01 grams per mole plus 1 times 16.00 grams per mole. So the molar mass of water is equivalent to 18.02 grams per mole. So I'm going to introduce you to something that we call Twin Peaks. So Twin Peaks is a tool that you can use to quickly remember the relationship between moles, the number of particles, and mass. These calculations will not be provided to you on an IB examination, so you need to remember these relationships. So as you can see, the mole, little n, is the central part of this entire relationship. So it's actually 2 overlaying triangles. So we learned this one the last lesson. So moles is equal to the number of particles divided by Avogadro's constant. So we know that one already. This one over here, the number of moles is equal to the mass of the substance divided by its molar mass in grams per mole. So little m for mass, big M for molar mass, little n for moles. Number of particles is big N, and then big Na is Avogadro's constant, which is 6.02 times 10 to the power of 23. And now we'll show you how to use this relationship. So there are a few rules to using Twin Peaks. So first of all, you can only work with 1/2 of Twin Peaks at a time. So you can't jump from, for instance, if we go back, you can't jump from mass immediately over to number of particles. You would have to convert to moles and then to number of particles. To solve for a variable, you cover it up and look at the remaining given values. So if we were trying to find moles, we'd cover this part up and we'd see, and we had the mass, we'd know that we need to divide the mass by the molar mass. If the values are side by side, you multiply them together, and if they're one over the other, you divide them. So as I demonstrated already. So to go from moles to mass, the mass is equal to the number of moles times the molar mass. So, or M equals little n times big N. So we're going to work through an example. So what is the mass of 1.25 moles of copper 2 oxide, or CuO? So we'll go about solving this. So remember, we'll write down our given values. So we know the number of moles is 1.25 moles. So that's our amount. We need to find molar mass before we can find the mass. So we have to calculate the molar mass of CuO. That's equal to the molar mass of Cu plus the molar mass of O. So we look up the value for copper. It's 63.55 grams per mole. And the molar mass of oxygen is 16.00 grams per mole. And that is equivalent to 79.55 grams per mole. So you're pretty much always going to have to calculate for molar mass. So you'll have to do a step before you can actually apply the formula. So our next step is to find the mass. So remember, the mass is equal to the amount, the moles, times the molar mass. So 1.25 moles times 79.55 grams per mole, and that is equal to 99.4 grams. So that's our mass. So the mass of 1.2 moles of copper oxide, 2 oxide, is 99.4 grams. In our next example, we're being asked to find the number of moles in 72 grams of H2O2. So this is our mass. We need to find the molar mass of this. So that's M equals, so there's 2 hydrogens, so 1.01 grams per mole, plus 2 oxygens, that's 16.00 grams per mole. So that's a total of 34.02 grams per mole. And we have 72 grams of the substance. So to find the moles, it's equal to the mass divided by the molar mass. So that is 72.0 grams divided by 34.02 grams per mole. So that is equal to 2.11 moles. So there is our answer. So the number of moles in 72 grams of hydrogen peroxide is 2.11 moles. So we can actually go directly from, we can go from mass all the way to number of particles, or particles all the way to number of moles, or mass, using Twin Peaks. It just is a 2-step process. So if we wanted to go from mass to the number of particles, the first thing you would need to do is convert the mass to moles by dividing by the molar mass. So we'd find the number of moles. Once you have the number of moles, once you're at that central part of Twin Peaks, you can then calculate the number of particles by multiplying by Avogadro's constant. So we'll work through an example. So in this problem, we're being asked to find how many molecules are there in 23.00 grams of sodium chloride. So the first step we have to do is find the number of moles in sodium chloride. So first we have to find the molar mass of sodium chloride. So the molar mass is equal to the molar mass of sodium. There's only one of them, and the molar mass of chlorine. So 22 or 23.00 plus 35.45 grams per mole equals 58.45 grams per mole. And then now that we have that, we can find the number of moles, or the amount. So N is equal to mass over molar mass. So we have 23.00 grams divided by 58.45 grams per mole. So this is going to be 0.3935 moles. I'm not going to round just yet. I'll save that to the final answer. So we found the number of moles. Now we need to find the number of particles. So to find the number of particles, remember, that would be capital N, and that is equal to little n, so number of moles, or the amount, times Na, Avogadro's constant. So that's going to be equal to 0.3935 moles times Avogadro's constant, 6.02, times 10 to the power of 23 molecules per mole. So that's equal to 2.369 times 10 to the power of 23 molecules, or formula units actually, because this is an ionic compound.